Number 15, the number of independent intensive variables that need to be specified to determine the thermodynamic state of a, assume this at equilibrium of a ternary mixture. So the component is equal to 3. Let's say you have 3 components A, comma B, comma C at vapor liquid equilibrium. So you can assume that there are 3 phases. One is liquid 1 phase, one is a liquid 2 phase. This could be miscible or immiscible, these two mixtures, and this is of course the vapor. So we have 2 liquid phases and the vapor phase. Each phase will component all the components A, B and C. So we have to find out the number of independent intensive variables, which is basically the degrees of freedom that need to be specified to ascertain the equilibrium of the system, which is both mechanical and the thermal equilibrium of the system. So what the and of course the chemical compositions, the phase equilibrium, which means the chemical compositions of all the phases will be constant and will not change with time. So this is a very simple problem. We apply the Gibbs phase rule, C minus P plus 2. Here the component is 3, A, B and C. Phases is 3. We have 3 phases, L1, L2 and the vapor, n plus 2. So that makes it 2. So therefore, any 2 intensive variables, it could be like temperature and pressure, it could be other intensive variables which are not directly asserted like Gibbs energy, entropy, etc. But these 2 are measurable intensive variables, temperature and pressure. So if you fix the temperature and pressure and you take all the 3 components and you just mix it well together and give some time to rest, after some time the phases will separate out and there will be a vapor phase on the top and the compositions of all these phases will be fixed. So the only 2 intensive variables need to be specified. So the answer is 2. So the C is the correct answer.